Hey, hi all. Welcome back to the channel again. Today we are going to discuss about the TypeScript generics feature. So how we can use that, what do we mean by that, and how we can give some kind of constraints to generics, and then can we define or create interfaces using that, and can we create a classes using that, and can we create or inherit a particular interface which is created using generics to the class which is created using generics, right? The generic interface which is getting implemented by the generics class. So all those things we are going to look into, but before that we need to understand what do we mean by the generics. So generics are nothing but the TypeScript feature which allows us to write down the reusable code, and which can be consumed by sending different type of parameters. Okay, and it will work upon the incoming types of parameters and gives us a desired result, right? So it allows us to add a placeholders for the types which we are going to send that function as a parameter, and we will get some kind of desired result. So what could be the problem statement over here? So let's understand why do we need to use the generics. So let's say I have a function type printval which has a name as a string type, and it simply logs whatever parameter we are sending, its value, right? So let's say print val. So if I call this function like this, let's say I'm passing test, it will print me the test as a value over here. But now if I want to use the same function with a different type of parameter, let's say I don't want to print the string over here, I want to print a number, I want to print object, or I want to print array, any other primitive data types, or any custom data types as well, right? So that is not possible using this method. Okay, so this is where generics comes into picture, and we can give a placeholder to this parameter. So let's convert this method to accept any type of parameter. Okay, so what I did over here, I just wrote down the t as a placeholder for this first parameter into angle brackets, and for this first parameter I give type as a placeholder as a t, right? And if I have another parameter, then what I can do, I can give placeholder for that as well. Let's say u. So this placeholder is depending on you. You can give anything, any character over there. Let's say a. I'm giving a as a type holder for that second parameter. Let's say name and location, location of type a. So a is nothing but a placeholder for that. Okay, so let's console.log location as well. Now as you can see, it gives me error. What error it gives actually? First of all, expected two arguments but got one, right? First of all, I do not call this, right? And if I hover on this, what it does, it actually has the two types of parameters, and for both parameters we have a different type of placeholders using generics, and the same placeholder type we have given to each parameter over here. And for using this, we may have multiple you know kind of, or maybe multiple variants of calling this function based on the parameters. Let's say I am calling this function by passing two string parameters, let's say LearnLift, right? And here I want to call this function by passing two boolean parameters, true and false. And here let's say 1 and 2 both are number. And let's say over here, let me pass first parameter as an array 1 2 3, and the second parameter as an object, let's say name, the key will be name and the value is LearnLift. Okay. So now what I can do, I can directly transfile this file and I can run index.js file. You can see all values has been printed over here. So it doesn't matter how you will, call this method and what could be the type of parameter you're passing. It doesn't matter. It will give you the result always, right? Anytime you call it, those many times it will gives you results without any kind of error, because here using generics we have given a placeholders. Okay, so this is how generics actually works. Let's understand what is the need of giving constraints on the generic types. Okay, so let's understand that by using a function. I just need to comment this out. We'll take a look into another example. Let's say I have a function called merge two objects into one. Function name is a bit lengthy. Do not worry about that. This is for the demo purpose only. In real time, we do not give this kind of function names. So let's say I have type 1 and type 2. So these are objects only. Let's say val1 of type t and then val2 of type u. So in return statement, what I am doing, I am just merging these two objects into one using spread, and let's console.log these two or the result of this method by calling it. Let's say the first property name is learn, then we have id field maybe in the first object. Let's say its type is nothing but number, and in the second parameter we are sending another object which name is lift, then the id which is nothing but 102. Let's say what could be the result of this. Transfiling this file again, running it, you can see name lift and id 102. The properties are same, that's the reason it omitted it. Let's update the properties over here. Let's transfile it again. Now we have updated the property name which are not same now, so it has merged two objects into one, right? So there might be some possibilities, it actually uses, or maybe we are thinking that we have given a placeholders over here, but based on the implementation, right? So based on implementation, we know that this function will be called to merge two objects only, right? For that particular functionality only we have wrote this function, right? But now accidentally, if someone has passed a boolean value over here, right? So this boolean value is also acceptable, because right now the type of this u is nothing but unknown type. Unless and until we pass something to it, it is an unknown type only. And now as we are passing the boolean value to it, so the type of this val2 will become boolean, right? And in this syntax actually boolean value is not acceptable. So now let's say if I transfile this and again run it, you can see name and id has been printed over here. Acha, let me save this. I did not save it. Now let me reprint it again. So you can see only the first value has been spread out into a new object, and val2 has been omitted because the type of val2 is nothing but a boolean type, right? So here comes a constraints concept where we can give a constraint for this placeholder to use exact type what we want to be included as a parameter to this function. So now let me create interfaces. Let's say interface employee, and here I can have emp id as a string and emp name as a string. Let's say another interface for the second parameter. We have student, which has student name as a string and student age as a number, right? Now I need to create two objects based on these two interfaces because I need to initialize the values for this. So what I can do, where obj1 of type employee id is a string, let's say 101. Employee name is a string, let's say test. So we have successfully implemented these two, or maybe initialized these two properties. And now let's say I have another object obj2, which is a type of student, and student id is, now we have a stud age as a number, let's say 5 years old, and now stud name as a string, let's say again test. Now what I want these two parameters of to be of type these interfaces. Okay, so now let's say the first parameter of type t I want. So what I can do, I can use extends keyword over here and give the type of it. Then the second parameter I need as a type of student, then I can do extends and I can give type over there as a student. So now what this statement is doing, right? This statement actually tells us that whatever type you are sending to this method as a parameter, it should be extends the employee's properties. It should extend the employee's properties, or it could be, or it should be the type of employee interface only. So now that's the reason we are able to now pass the obj1 for the first parameter and the obj2 for the second parameter, right? So now the return type of this is nothing but t and u. And if you are wondering what is this t and u, you can go and watch my video of intersection types and type assertions. So we are using both concepts over here. So we are asserting the type into this angled brackets, and we are given as a type for this function using type intersection, using this and keyword over here. So both concepts we have discussed in deep into that video. You can go and look into that as well to learn more on that. So now as you can see, it doesn't give me any kind of error and it will print the desired result as it is. So let me run the file. You can see both objects are merged into one, right? So this is all about the constraints. In some real real case scenario, we need to have the constraints on the type, because we are not allowing any kind of parameter which has some fishy data into that. It should be type of the interface what we have you know created as a model, and which is kind of replica of a database table we have created at a front end. And while sending data to the database, we should need that data only, which should be fit into the data table at the database level, right? So we should have that kind of data only in our hand or to be processed in the method as well. So now if we wrote this method to get, you know, response, the two table response maybe, and if we want to merge those and for the, sake of showing it on a UI and combining them and looping through them and showing the whatever values we have, right, at different place on the web page. So we can use this method and we can pass the employee type and student type objects to this method and to be processed and get some results, and we can have a loop into this and we can show whatever results we want to show on the web page. So this could be a real scenario where we need to, give some kind of constraints on the placeholders. So now let's understand how, we can create a generic interfaces as well. So let's say we have these two interfaces. Now interface employee of type T, I can do like this over here, and interface student of type T. So I can give placeholder to this employee interface and student interface over here, and I can use this T as a type of this, properties, so that I can have my own typed, properties into this employee interface. Okay, and the same goes with the student interface as well. So if I want another property, something like string, so you can give, or maybe this, the T is nothing but a string placeholder and U is nothing but a number placeholder. So what I can do, I can give that number placeholder to this student age key. Okay, so now when I use this employee, I need to pass the string parameter over here, and it will be initialized with the string values for each and every member of it. And now for student, let's say the first parameter is string and the second parameter is number, right? So number we have used for the student age and a string we have used for the student name, right? So this is how, you can create interface with generics. So you just need to give the angle brackets, and inside angle brackets you can give the type holders, the placeholders for the types. Okay, now let's try to create a generic class. So to create a class, we need to write down, okay, let me console log this. To create a class, we need to write down the class keyword, then the name of the class, let's say test class, and here you can give type. After the class name, you can give types T and U. Let's say I have two members of those types. Let's say name of type T, then let's say location of type U. Okay, so I'll have constructor, and inside constructor name of type T, then location of type U, and I'll just initialize this dot name is equal to name, and this dot location is equal to location, right? What I can do now, I can just add some getters to it. Get name of type T, it will return me this dot name, because name is also of type T only. So now get location, and the type of this is U, and return this dot location, right? At the end, the type of location is also U, and the return type of it is also U. So now what I can do, I can just initialize this class using one object. So let's say where obj3 is equal to new, maybe test, and over here you see it is giving me error. Why? Because the expected arguments are 2 and we did not given any kind of arguments. So let's decide what kind of arguments we need to pass, right? So we have given two placeholders over here for the types, and we are mentioning those types over here. Let's say first parameter is string and the second parameter is number. So what I can do, I can pass test for name and 101 for location, right? um, okay, we already have a obj2 type, so let's say obj3 over here. Now console.log, we have getters for these two properties. Let's say obj3.getName, getName, and obj3.getLocation, right? So by doing this, we are getting the name as a test and getting location as 1001. Okay, let me save this file, transfile it again, and run that file. You can see the name and 1001 we got actually from the class. So this is how you can create a class as a placeholder, and now over here you can initialize this class with any type of data type. Okay, so you have a chance to initialize this class with any type of data type using this two type placeholders, and based on that type only you can initialize the constructor as well. Let's say I want boolean type over here. So you can see there is a red line coming from below the first parameter. So I can change the parameter type to true over here. Let's say instead of number I want a array, right? So what I can do, I can just pass the array over here 1 comma 2 comma 3 like this. Let's say number array, right? Or I can pass objects array, I can pass string array, anything I can pass. It's the all control is actually in my hand only. Okay, so I can use this method n number of ways according to my needs. Okay, because I have a placeholder, so on the place of placeholder I can pass any type over here, and based on this type I can initialize with those type values only while I create object of this particular class, right? So this is how it is. So let me clear it, transfile it again. You can see true has come over here and it has been printed. It has printed the array for us as well, right, in the place of location. So this is how we can create classes using generics, and we can create a common class. So this we have created a common class, and over here we have created a common interfaces, right? Those we can use anywhere as per our need, and we can pass any type to them, and the properties will become of those types only, right? So this is the beauty of generics, right? Now let's see how we can inherit this employee into this class, right? So as you know, to inherit interfaces you need to use implements. Let's say employee. Now we do have employee, let's say type T over here, right? So now it has some properties, right? emp id and emp name. Let's implement that as well. emp id of type T and emp name of type T we have. So at the place of T, what we are passing? We are passing boolean, right? So let's say what could be the value of it. Console.log obj3.empid and then obj3.emp name. Now let me save it, clear the console, transfile the file again and run the file. you can see undefined and undefined has been printed over here, right? That's correct. We did not, initialize this property. Let's say emp id of type T and then emp name of type T, right? So we need to initialize these properties. This dot emp id is equal to emp id, and then this dot emp name is equal to emp name, whatever we are getting from the constructor, right? So now let me add getters also. We did not add getters for this, so let me add a getter for this. Get emp id, right, of type T. It returns me this dot emp id. Let's add again one getter. Get emp name of type T. Again it returns me this dot emp name, right? So now if you look at this in the console, I'm clearing it, and if you look at this class, it gives, it gives us error that it is expecting 4 arguments but got 2, right? So what happens over here? So let's give emp id as a boolean now, true, and then emp name as a boolean, true, because as you can see, the same type, the first placeholder we are passing to the uh, interface as well, right? And we have given the same T as a placeholder in the constructor as well. So that's the reason whatever comes at the first place, it is expecting that type of parameter over here, right? So now if I transpile this again, index.ts file, and if I run index.js, you can see true has been printed over here, right? So in this case, if I want to use any different type for the interface properties, I can use v. I can give another placeholder as a v, and I can pass that v to this, right? And now I can change the type of the interface properties again over here and in the constructor as well. Now I can give another property over here, property type as a string, let's say, right? And as you can see, the red line over here, let me convert it into string, and the red line over here as well, let's convert it into string. So let me give learn over here, and let's give lift over here. Let me transpile this again. Okay, return emp name. Okay, so I need to update a type over here into the getters as well. Let's save everything, transpile it, run it again. Now you can see no learn and lift has been printed, right, as the value of these two variables, right? So this is how you can implement any interface with the types. So now let's say we need to implement this interface as well, student interface as well, which has two types, right? So let's say comma student, and here again we need to pass two types. So let's say v and w, right? So let's pass v as a first type and then w as a second type, comma w, right? So now we need to implement these two properties, the student name and student age. Let's say student age is of type w and student name is of type v, right? So now again we need to initialize it somewhere. Let's say student name of type v again, and student age of type w, right? Now this dot student age is equal to student age, and this dot student name is equal to student name, right? I'll just add these two getters to this. let's say instead of get empid, stu name of type v, and it will give me student name, and let's get the student age, stu age, and the type of it is actually w, and then return me the student name over here, right? uh, okay, actually we have w for the student age, that is right. Okay, we need to return the student age over here, right? So let's use these two properties to console log. The first one is student name, then we have student age, right? Now as we have introduced one more placeholder over here, so let's introduce that placeholder of, what kind of or what type of placeholder it is, right? So we have boolean array string. Let's have number over here, right? And then if I give comma over here, it is expecting student name as a string. Let's write down test as a student name and student age as a number, let's say 5, right? So now this class has been initialized and it is actually extending or implementing, sorry, not extending, implementing two interfaces, right? This is the first one and this is the second one. Now for the first one, we are passing the same placeholder what we have for the class, and for the second interface we are passing these two placeholder as it is over here, and we have implemented these two properties with the placeholder, right? And the same properties we are initializing in the constructor, as you can see. And now over here we are passing the actual, you know the data type for those properties from here while creating an object. And for the same data type we are giving the same data type value over there, right, in the constructor, so that the value should be initialized with the correct value. Now let's clear out the console, transpile it. Now you can see the test has been printed for the student name and the student age is nothing but 5, right? So this is how, we can have this common class with common interfaces implemented inside it, right? And we can have these two interfaces written in a common, at a common place. We can have a method which returns us a common, functionality, and we can give some constraint on that, like the constraint on the parameters, what could be the value of the parameter, or the what could be the type of that parameter, the future parameter type, right? So we can give that over here as well. So we have learned what is generics, what is generic constraints, how we can create generic interfaces, how we can create generic classes, and how we can, inherit generic interfaces into generic class as well, right? And how to initialize the values, how to pass the placeholders, you know, to the interfaces we implement, and how to initialize values, how to create object of that particular class, and how to decide the values for these placeholders, right? The placeholders we have, written over here. We can decide the value for those placeholder in the angle bracket while creating the object or calling the constructor of that particular class, right? So I hope you have understood. I know that this video has become a lengthy video, but we have covered everything whatever you need in the concept of generics in TypeScript, and this is all it is actually. So I hope you liked the video. If you like it, so then you can like the video, hit like button, you can share this video with your friends, and do not forget to subscribe the channel, hit the bell icon before leaving the video. Thank you all guys. Let's meet in next video.